Hello everyone, welcome to this video tutorial on how to solve truss or how to analyze a truss using the method of joints. Let's look at the question. Okay, this is the example. Determine the force in each member of the Pratt bridge truss shown above. State whether the member is in tension or in compression. So we have this truss and we need to determine each force in each member of the truss. So that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 members, and we have to state whether the force in the member is in tension or in compression. Okay, we will start with finding the reactions at the supports A and H. Let's do that first. At A, we have a hinge, and the reactions should be AX and AY. We have a roller at H, and we have a reaction of HY going upwards. So, how to find the reactions? We find the summation of the forces in the X, and that set to 0, and we find the summation of the forces in the Y direction, and that should equal to 0 as well. And we need to sum up the moments about a point, and that should equal to 0. If we do the summation of the forces in the X direction, we'll end up having AX equals to 0. There are no external forces that act in the X direction, so the reaction in the X direction should equal to 0. Now we'll do the summation of the force in the Y direction. We'll have AY minus 6 plus HY will equal to 0. Or simply we can write it AY plus HY equals to 12. And that should give us the first equation. The third equation is the summation of the moment about a point. Okay, the total number of unknowns we have in this problem is 3. That's AY, HY, and AX. We already got a value for AX, which is 0. Now we'll try to eliminate one of these unknowns by using the third equation. And how do we do this? Simply, let's try to take the summation of the moments about a point where one of the forces AY or HY passes through it. I chose A, so I take the summation of the moments about point A. The summation of the moments about point A will equal to HY times the distance from H to A, which is 3 plus 3 plus 3 plus 3, that's 12. And the rotation or the direction would be positive moment if the direction is counterclockwise. That's just an assumption. Okay, so HY times 12, that's a positive. Then plus, this plus is just the summation here. Then we have the force 6 multiplied by 3 plus 3 is 6. So this force is going this way, which is negative, because it's opposite to whatever we assumed here. So that's the negative sign right here. Okay, the last force, which is 6 kilonewtons, times this distance, which is 3 meters, and that would give us a negative rotation. Again, this force is rotating this way, which is opposite to whatever we assumed here. Now if I solve this equation, I'll end up having HY equals 4.5 kilonewtons, and if I substitute this value back into equation 1, I'll end up having AY equals 7.5. And that's how we find these 3 reactions. Okay, now we're ready to start picking the joints we will be using. Let's try to do this. Yeah, we have so many joints in this truss. We have A, B, C, D, E, F, G, H. That's a total of 8 joints. The trick in picking a joint is very simple. First, we have to pick a joint that has only 2 members with unknown forces. For example, if I pick joint C right here, we'll have 3 members, CE, CB, and CA. That's a bad choice. But if I chose A, joint A, that's 2 members, A, C, and AB. That's perfect. Plus, it's going to be very helpful if the joint I chose would have an external force with a known magnitude. Let's say AX or AY. In this case, AX, of course, it's going to be 0, and AY is 7.5. So it's a good choice to start with either A or H. I started with A. So we have the joint A, and we need to assume the following. First, we draw the joint. Second, we draw the members. That's AB and AC. And I will assume that the forces are in tension in these 2 members. If my assumption is correct and my number is positive, one of these numbers, the forces, I mean, in the members. Let's say we have AB, and I did the calculations and everything, and I got a positive value for AB. That means my assumption is correct, and the force is in tension in AB. And if I got a negative, that means the force is in compression. Okay, so draw the joint, draw the members, and draw the arrows pointing away from the joint. Third, we will add the external force to our joint. Now, in order for me to apply the equations of equilibrium, that's sigma fx and sigma fy, all of my forces should be either along the x or the y. So all I do is just resolve the AB force, for example, to its components. So the components of the forces that's shown right here, it's 4/5 times AB. That's the y component, and the x component is 3/5 AB. And of course, AC is already resolved. It has only one component, which is along the x direction, the positive x, and the 7.5, the reaction AY, is acting along the positive y. So now I'm ready to use my equilibrium equations. Let's do the sigma fx. We have AC, that's the AC, plus 3/5 AB, that should equal to 0. So that's my first equation. Second equation would be 7.5 plus 4/5 AB, and that's equal to 0. It's right here. From this equation, I can solve for AB, and I'll get a negative value, which means I assumed the force to be in tension. Now it's in compression. Now I take this value and substitute it back in equation 1, and I get a value of AC equals to 5.63. This way I already solved for the members AC, the forces in the members AC and AB.